So let's go up to the CUCM server and look at location. And we'll open our hub none, branch 1, and branch 2. And we'll talk about hub none in just a moment and what's special about it. First of all, note that we can't change the name, nor can we add or delete it. All the others, well, I shouldn't say add it. We can add new from this page, but we cannot delete that one. All the others we have the ability to delete. So it is special in that regard right off the bat. Can't change the name, can't delete it. We have our audio calls set to unlimited because we were told we weren't allowed to enter a value. Now if we were, we know that the value for G729 calls per call, since this is dealing with call admission control, is 24K. And if we had forgotten that, help for this page would certainly quickly remind us. Let this load here real briefly. And we can see that G711 uses 80K, so on and so forth. G729 uses 24 kilobits per second per call. Okay, this is for the purposes of location bandwidth calculations only. Note the only word that they put in the documentation. This means this has nothing to do with your quality of service. This just means if you want to allow 10 calls and you want them to be G729, multiply 10 times 24 for a value of 240. How do we make sure they're G729? Because 80K, 240 could certainly house a number of 80K calls, right? Well, how would we make sure? Because of regions. But we were told we weren't allowed to use any value there. So what this was alluding to is that we needed to use location-based RSVP. Now, before we talk about RSVP, if we had put a value here, let's say 8 times G729, and using a calculator is always a good idea. You have one in the lab. So 8 calls times 24K per call is 192 kilobits per second. If we did have a value here, and we had told, and again this is a matrix, just like we looked at with regions, between hub none and between the branch 1 location, we were told mandatory video desired. And we'll talk about the different options here in a moment, but our RSVP said that RSVP was essentially mandatory. So between corporate headquarters, or between hub none and branch 1, RSVP is mandatory, and we're saying for the hub none location, 192K. Now actually that would go in the branch 1 location, but I just want to touch on something. If we have both of these, what we're essentially telling the server is that you have to use both traditional locations-based call admission control, or CAC as I'll call it, and you have to check RSVP. So first, does it meet the criteria of falling within this value and the available bandwidth remaining in this value for what we currently have going? And we can use our TMT and our system parameters, our our performance monitor counters and statistics to tell how much bandwidth we have left. But does it fall within the remaining available bandwidth? If yes, then secondly, go and check RSVP and make sure that the routers, the actual infrastructure path, has enough bandwidth. Okay? It's not a good idea to use both, but if I did have it configured that way, that is what it would do. It would still allow the call, assuming that I both had enough available bandwidth in CUCM and the actual inline infrastructure path had enough bandwidth as well. Okay? Get rid of this calculator. So next, let's just take a look at, we want to leave it at unlimited as the desired preferred Cisco recommended way if we're going to use RSVP. So with RSVP, I say from hub none to branch 1, and I can select multiple. Which do I want to use? System default says go back to service parameters and check that value. No reservation is basically the system default. That is no RSVP. Optional with video desired means try to reserve the audio path and try to reserve the video path. But hey, if you can't do either, well, then that's okay. And actually what it does is it goes to another service parameter that says if the optional RSVP failed, in other words, we could not reserve the proper bandwidth, what should happen to the DSCP quality of service markings. And we can actually do something else like set those back to the default is best effort. And when we get into QoS, we could talk about more of that. Why? The main reason why we wouldn't want to leave it at the DSCP-46 for voice is because if it goes into the priority queue and there's not enough bandwidth left in the priority queue because we had sized that up properly to be in conjunction essentially with the number of calls and bandwidth used for call admission control in RSVP, then what happens to a priority queue with no bandwidth left? Tail drop, right? So all of a sudden our voice would begin to be dropped, but it wouldn't just be the last call in, it would be random packets and bytes and calls, so it would be a degraded performance and quality for many, if not most, of the people running voice through that priority queue. So that's the idea behind optional. We don't need it today. Mandatory says if an audio-only call was required, mandatory, there has to be enough bandwidth or else a reject. If video call was required, then both have to be available. Now, this would be great between a site or a call admission control site that you used for telepresence or any sort of video conferencing. Because if video isn't there, you don't want an audio call, most likely. For phones, you can also, most phones have checked in the device, retry video call as audio call. So in other words, if we had mandatory, without mandatory video desired, mandatory set up, then if the call failed, it would retry it as an audio call. And then we have mandatory with video desired. This is what we'll typically use. This means audio is mandatory. If there's not enough bandwidth, have a failure, okay, which would come back to the CUCM, not enough bandwidth, and then CUCM could decide whether to engage AAR for automated alternate routing or not, depending on configuration. But if a video call is required, or I should say a video call is attempted, then try to reserve the bandwidth for video, but if not, still allow the audio call to go through. Just reject the video portion. Okay, so that's our corporate headquarter hub none to L branch 1 and 2. Looking at branch 1, we've got it to hub 1 hub none and branch 2, mandatory video desired, and from branch 2, hub none and branch 1. Now, let's look real briefly on any phone. And I don't know exactly how I have this phone set up, but let's take a look. Okay, good. I have this phone, which is a branch 2 phone 2, the N3002. Its location is set to hub none. Now, why is it called hub none? Hub underscore none. Is it the hub location or is it the none location? And what would the none location be? Well, notice what's above this. Network audio source, user audio source, media resource group list. They're all set to none, right? There's values available, but they're set to none. Does this mean that it doesn't have a media resource group list? Or that this branch 2 phone doesn't have any audio sources able to be played for user hold or network hold? No. It just means none go back to the previous entity and use its configuration. In this case, the device pool. So look at the device pool, which is set and has to be set. Click View Details on it. And if we drag this window over, we see that the values that weren't set, like MRGL, well, we've got an MRGL. And what about audio, user and network audio source? Well, let's see. Nothing set here, so we could simply go back to the next step, which is the service parameters. Okay, so we always go back to the next step. So the same thing is true in the case of location. If location is set to hub none, if it's on the device, we're really considering it as the none location, which means go back to the previous entity or the device pool. Click on the device pool, bring it up. What does the device pool have for location? L branch 2. So this phone is using L branch 2 as its location. And a simple way to test is to place a call and see if RSVP gets triggered to see if there's enough bandwidth for the call. Okay, so then when is it hub? Well, now let's go back to actual device pools. If I'm on branch 2, and this is set to location branch 2, well then that's what it is, location branch 2. But let's go back to corporate headquarters, and it's set to hub none. So now it's not none because there's nothing above device pool. Well, there is. It's service parameters. However, there is no default location. So because there's no default location, in this case, it is the last level, so it is actually using hub, okay, or the hub none location. So anywhere that it's just a phone device or a, media resource, you might be commonly used to configuring the actual location there, but you can leave everything at hub none and configure them at the device pool. Okay, so now we need to take a look at our, well, let's just go look real briefly again at our phones. Let's look at phones instead of beginning with directory number, beginning with device name SEP. They've all got their proper device pools. Let's click on corporate headquarter, branch 1 and branch 2. Corporate headquarter uses location hub none. Branch 1 uses L branch 1. Branch 2 uses L branch 2. So now we want to take a look at our actual router. And let's do a show IP interface pipe to exclude unassigned. Oops, sorry. What I meant to do is show IP interface brief pipe to exclude unassigned. And we see our basic interfaces with IP addresses. Unassigned would be the IP address unassigned. And what we want to do is we want to look at the layer 3 path. So over to our branch 1 site is this serial link, and over to our branch site is this serial.2 subinterface. So let's do a show run interface serial 001:0.1 and .2, and we see that we've got the IP RSVP bandwidth command of 208 and 352. Now we were supposed to have 8 calls and 14 calls. So where did we get these numbers? Let's bring up a calculator again, and this time I'll drag it over to view. So if I had 8 calls times 24K, that's 192, not 208. And if I had 14 calls plus, 14 calls times 24, basic first grade math, then we have 336 as the value, not 352. So where do we come up with these values? Well, RSVP in the iOS routers does use 24K for G.729. However, it doesn't know the sampling rate at which you're going to be sending calls. And remember, RSVP was around a lot longer, a lot before even CUCM had the ability to use it. Really, it's been around since, 97, 98. Now, back in the day, we only ever heard of RSVP in conjunction with IntServe, or integrated services. What we typically use for quality of service these days is differentiated services code point. So instead of integrated services, we're using differentiated services, or differentiated services code point, or DSCP. Now, integrated services say that RSVP calculates and determines how much bandwidth should be used to allow a call to pass through, and or has a total calculation of how much bandwidth should be allowed for calls to pass through a given data plane. The nice thing is it's actually in band with the data plane. So one of the problems with traditional locations-based CAC is that we have an out-of-band solution. We just have these ethereal entities called locations. But what do they really mean? I mean, they represent a location, probably geographical, but not necessarily. And how do we get from one location to the other? You might say, well, we have enough bandwidth. Well, right, but where does that bandwidth come from? I don't know, T1, T3, E1, E3, Metro Ethernet, OC48, OC192, some sort of link. Right? So what if I have multiple links of different speeds and one goes down? If I have multiple links of different speeds. I might add them up, decide how much do I want to use, maybe 33% of each link, give that to the location. But what if one goes down? All of a sudden, there's been a dynamic change in the topology in terms of available bandwidth, but my dumb CUCM entity locations doesn't know anything about that. I shouldn't say dumb, unintelligent. It doesn't know anything about the topology change. Well, RSVP does. It's in band, it's in the line of the packet, and it's per interface, so per link. So I could have multiple links, unequal, equal, load balance, non-load, it doesn't really matter. If a packet's going through that interface, that's when it's going to trigger that RSVP to send the reservation messages forward and get the path messages backwards to say, yes, you have a path here, here's, if you have the path, there's enough bandwidth. Well, going back to the old integrated services module, when it said there was enough bandwidth, so I send a reservation message forward, and the next router sends a path message backwards saying, yes, you have enough bandwidth, the integrated services not only reserved the control plane, but it also reserved the data plane. So it actually did a hard reservation of that bandwidth. So if I reserve 24K on a, let's say, a low speed, 128K CIR and 128K port, old school frame relay link, that 24K was gone. So I now had 104 kilobits per second left of bandwidth that could be used. It was gone. It was reserved in the data plane of the router. Remember the three planes of the router? We've got the control, the management, and the data. Okay? When we use RSVP as a RSVP agent, which we're going to look at how that ties into CUCM here in just a moment, what happens is we reserve the control plane of the router, reserves 24K, but we're not tied in with integrated services. It's just relaying that information back to CUCM. And the router keeps that information about the control plane reservation. But the data plane isn't actually reserved. Okay? So only when RSVP is tied in with IntServ or integrated services is the data plane reserved as well as the control plane. When we're using it with DSCP and with CUCM as an RSVP agent, it's only the control plane. RSVP knows that now there's one less G729 call, or 24K less of bandwidth that can be used out of the total available bandwidth that I configure here in this number, 208, which we're getting back to why it's slightly higher. But it doesn't reserve the data plane, so the bandwidth is not actually reserved. That is left for when a packet enters the priority queue. Okay, so now why is it higher? Well, RSVP doesn't know whether this is a 20 or 30 millisecond sampling packet, what the sampling rate was. So basically it takes the worst case scenario into consideration on the initial call setup. Now once the call is set up, it will settle back down. But if I had a G729 call at a 30 millisecond sampling rate instead of the default 20, I am sampling more information, the packet's going to be bigger, and so it would actually be a 40K packet for a G729 call. Now you don't have to take that into consideration when you're using traditional CUCM only locations-based CAC. It's 24K regardless. But for RSVP, we need to basically say that, so 40 minus 24 is 16. So there's about a 16K overhead per call that could be negotiated. Now you might say, well, 8K times 24 is 192. 8K times 40 is 320. 320 minus 192 is 128 divided by 24. That's 5 additional calls that could get in. We don't want that into the call admission control. We don't want to allow that. That's true. And it's only reserving RSVP in the control plane only. It's only reserving that amount until it sees how the call finally settles down and behaves, and once everything is negotiated. Essentially once H245 or SDP, or if it's SIP, skinny, whatever is finally negotiated in terms of millisecond sampling rate and so forth, how much bandwidth is actually going to be used, that's when it will see, oh, only 24K is being used, so it will settle down. So basically, for each new call into the RSVP reservation control plane mechanism, we have to allow for each new call. So that basically means the next call. So not just the first call, but every next call. So basically what we do is the formula changes from n times 24, or number of calls times 24, to number of calls times 24, so 8 times 24, plus an additional 16K overhead for the first call, and once that settles down, the next call, and once that second call settles down, the third call, and once the third call settles down, the fourth call, etc. That's where we get the 208. Okay, so same thing for 14 calls times 24 plus 16K overhead is the 352 mark. And of course, we need that on the other two routers as well. So we've got the 208 on the branch 1 and the 352 IP RSVP bandwidth on the branch 2. Now, how is that information triggered back and forth from CUCM? Well, this is the purpose of the skinny MTP agent. So we'll do show run pipe 2 section skinny, or let's see, CCM group, or we want DSP farm. Now let's do MTP. Okay, so we see that we've got our skinny commands defined, pointing to the sub and pub, our skinny group, our bind interface, associate, the CUCM that we just defined, identifier 2, identifier 1, identifier 2 and identifier 1. So identifier 2 is the sub. We're going to put that as the priority 1. So the sub will be first and the pub will be second. And we've got a couple MTPs. Now G729 is where our calls are going to be going through the WAN. So that's the reason we only have this RSVP keyword, which RSVP enables, or RSVP agent enables this MTP for the G729, because those are the only calls that we're passing through the WAN. We do have a DSP farm for MTP for G711, but that's just for calls that are within the corporate headquarters site that also need an MTP to assist. Remember, an MTP is not a transcoder, but a transcoder is also an MTP. So with this, and with the fact that we're using maximum sessions software command, we're not using any DSPs, and in fact, we do not need the DSP farm services, or DSP services DSP farm command under the voice card. We would for things like conference and transcoder. Okay, so we see that they should be registering. Show skinny shows that, let's see, this is our transcoder. That's active. MTP is active for G711. MTP is active and connected for G729. And our conference is in progress, but we're not really caring about that because we're not doing that portion yet. Same thing with all these. Show skinny. Pipe to begin with MTP. Oops, capital MTP. And we see that our MTPs are connected and registered. And same thing. Our MTPs are connected and registered. Looks like we have two G711s. Let's do show run pipe to section DSP farm. And looks like we do have two G711s. Looks like when this one got set up, by default the codec is G711, and it looks like the no G711 codec was not properly entered, which of course we have to shut this down first. No codec G711. If we try to just say codec G729 without R8, no shut, no skinny, skinny, then it wouldn't have worked. So let's do that again. Okay, now we've got our RSVP enabled G729. Let me just check that other one. Show run pipe to section DSP farm profile. And we do have a RSVP enabled G729 there. Good. Show skinny pipe to section MTP. Let's just do begin with MTP. And we've got our G729 MTP registered. Good. We'll save that. And we'll go back over to our CUCM, where we look at our media resources, our media termination points. And we've got our G729 for branch 1, one for branch 2, one for corporate headquarters. We'll bring up branch 1 and note that there's nothing special we need to check here. When the iOS router registers to the CUCM, it registers this MTP as an RSVP-enabled MTP. Going back and looking for that same branch 1 site, it's got a G711 MTP as well as the G729, and because it wasn't specified in the iOS, the G711 registered as a non-RSVP-enabled MTP, the G729 registered as a RSVP-enabled MTP. Okay, and then of course those need to be in media resource groups and in media resource group lists that we'll take a look at later and available to the devices. And then the routers have the ability to use them. So let's do debug, IP, RSVP. Let's do messages. And we'll do the same thing over here, debug IP RSVP messages. If I can type, keep hitting the wrong key. Okay. And should have turn on already turned on, but we'll go ahead and turn it on just in case. And if I place a call from let's say corporate headquarter phone 1 over to the branch 1 phone 1. Oh, sorry, that's branch 2. There we go, branch 1 phone 1. And we'll set screen refresh to 2 seconds, which sometimes can be rather quick. But we'll see if that works well for right now. And we place a call from 1001 to 2001. And the call rings. And we go ahead and we'll answer the call and put it on mute. Then we see that we had an RSVP message go out. And let's see, let's actually do another debug as well. Debug IP RSVP reservation and path might actually be a little more of what we want to see. We'll tear that call down. Let's undebug all, debug IP RSVP path and reservation. And we'll try that same call again. And here we see a lot more information. We see that we successfully parsed it. Okay, new path. We're admitting the new reservation. Starting requesting 40K. Notice that. Okay. Now we're requesting 24K. It's fallen back and realized that's all it's using. And router 2 was talking back to it, of course. And so we've got this set up properly. Show IP, RSVP. Let's just say show IP RSVP. That's a little too much information. Let's say request. There we go. So from 177.1.254.2 to .1, the loopbacks, we've got bandwidth per second reserved 24K. So you saw the initial 40K, and then it quieted down to 24K.